As someone who likes to collect and digitize lost media, this recent eBay listing really caught my attention. I'm also a history buff, and I love to uncover things that might have aired only once on television or have been lost to time either way. So a vintage Sony videotape, V32 for helical scan recorder, 1969 Man on the Moon Eye, really did catch my attention. Could this be a television recording on a half-inch reel of the moon landing? Well, maybe. So I decided to put in a bid for it, and my offer was accepted. And I do happen to have something to play this. Yes, I do possess a half-inch video recorder and player. But even if this is the moon landing, or something else, it's going to be a bit of a process to get this thing running. Let's take you through it. But first, we gotta wait for the package to arrive.
1 week later.
Alright, so here we got our tape. You can see it says here, Man on the Moon 1. This is the outer cover. And something interesting you'll note is that it does have a date stamp of July 1st, 1969, which would be the month that the moon landing occurred. So the first step with any EIA-J tape, especially being one that is nearly 60 years old, is we need to prevent what's called sticky shed syndrome from ruining my machine. And how we do that is we need to bake this tape to get all of that sticky residue off. These tapes being as old as they are, the way they were not made to last this long. And even though this is in pretty good shape, no mold spots or mildew, I'm still always going to be safe and bake these. And that's going to go at 155 degrees Fahrenheit for somewhere between 4 to 6 hours. That should remove any of that stick that's on there and prevent it from clogging up my machine. So we just plug in the old tape baker. As you can see, this is a Nesco snack maker food and jerky dehydrator. You know, people can spend hundreds up to thousands of dollars to bake their tapes and buy these really fancy machines, but I found that just a $100 jerky maker from Amazon does it just fine. So we got that fired up. Let's open her up. I like to leave some padding between the top and where the tape is being baked, so we'll leave that there. And let's say, figure, let's do 5 hours.
5 hours later.
All right, 5 hours has passed. Let's unplug our machine. Unfortunately, there's no power on or off. This thing just turns on when you plug it in. Take off the top. You can see, being at 155 degrees, this did not melt the tape. If any of you are worried about this process, at that temperature, not even close to melt, but it can remove that chemical stickiness. So it's definitely warm. We'll let it cool off for a few minutes, and then we need to put it on the machine. And we're not ready to play it just yet. It needs to be physically cleaned, because during the baking process, all that gook that came off it is just sitting on the tape right now. So in order to, again, prevent distortion and give us the best picture possible, we are going to clean this puppy. So let's put it on. What we have here is the Sony CV2100, one of the world's first home video recorders. Long before the VCR or the U-matic player, this was the only way to get footage off the television. This was made in 1965, and it records in what we call a skip field format. You might see half-inch videotapes such as this that look exactly like this, but won't be able to be played on this because they were recorded on an AV model, which came a few years later. So this is indeed a skip field tape. I've already tested it, but let's try and spool this around. Again, it's hard to do with one hand. And we're going to start cleaning this thing. So it just goes around the head drum. So now that the reel is on, I'm going to take one of these TX304 Tex wipes, which are great 100% cotton cleaning pads. They don't shed, they don't damage anything. And I'm going to wet it with some 99% isopropyl alcohol. And it's really important when cleaning tapes or doing any sort of work with electronics that you use 99% alcohol, because there's no impurities, there's no additives that could mess with your electronics. So that's been dabbed, and now I'm going to take off the cover so I have easier access to the tape. And I'm just going to wedge that wet part on a spot in the tape that I can firmly get a hold on right here. And then I'm going to fast forward and clean the tape. So let's do it. Alright, so it's moving. And again, I'm just cleaning off all that gunk that came off during the baking process, and also any other dust and dirt that might have accumulated over this tape's nearly 60-year lifespan. I just paused for a second because look, I've only been doing this for about 10-15 seconds and there's already a solid layer of dirt and grime that's coming off. We do not want that going onto the tape head, nor do we want it affecting our playback. So let's finish this thing up and then we'll rewind. Should be almost done. We cleaned the whole tape. Now we're just rewinding. Alright. So now I'm going to give the heads here just a little bit of an alcohol clean. That bar is actually the head, so that spinning really, really fast is what creates the video signal. So I just wet alcohol. I'm just going to clean each side of the heads. Apologies for my arm. And we should be good to go. So let's wrap this thing back up and we'll get some signal. First things first, when using an old machine like this, the signal can be a little confused about how to get onto a digital format. That's where the time-based corrector comes in. This one is made by Hortronic. It basically just stabilizes shaky video and fixes any issues with the signal. So now that that's up and running, let us see. Moment of truth. Is this the actual footage of the moon landing from a television broadcast, or is this just a waste of my time and money? Showtime. Well, I'll be damned. Holy wow. I think this is the real deal, guys. Huh.
Eagle, you're looking great. Coming up 9 minutes.
Wow.
We're now in the approach phase. Everything looking good.
I think this is it, guys.
200 feet.
Alright. I'll rewind this back and get a full digital copy to you soon.
Copy.
And then we'll debrief.
It's in your go for landing.
Feet per second.
It's the P-64.
Good. Roger. Fido says we're go, altitude 9,200 feet.
830, you're looking great.
Descent rate 129 feet per second.
We copy. Eagle, you're looking great. Coming up 9 minutes.
We're now in the approach phase, everything looking good. Altitude 5,200 feet.
Manual attitude control is good. Roger, copy.
Altitude 4,200.
Houston, you're a go for landing, over. Roger, understand. Go for landing. 3,000 feet.
Copy.
Alarm. 1201. 1201. Roger, 1201 alarm. We're go. Same type. We're go. 2,000 feet. 2,000 feet. Into the ag. 47 degrees. Roger. 37 degrees. Eagle looking great. You're go.
Altitude 1,600. 1,400 feet, still looking very good.
Roger, 1202. We copy it. 35 degrees. 35 degrees. 750. Coming down to 23. 700 feet, 21 down. 33 degrees. 100 feet down at 19. 540 feet down at 30. Down at 15. Take 400 feet down at 9. 8 forward. 1050 feet down at 4. 33.5 down. They're pegged on horizontal velocity. 300 feet down 3.5. 47 forward. Put up. On 1.5 down. 70. Got the shadow out there. 50 down at 2.5. 19 forward. Altitude, velocity light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 160 feet. 6.5 down. 5.5 down. 9 forward. Good. 120 feet. 100 feet. 3.5 down. 9 forward. 5%. 185. 75 feet. Car's looking good. Down a half. 6 forward. 60 seconds. Lights on. 6. Down 2.5. Forward. Forward. That's 40 feet down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drifting to the right a little. 20, down a half. 30 seconds. Forward. Just. Okay. Contact light. Okay, engine stop. ACA at a descent. Auto descent. Mode control both. Auto descent. Engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Thank you. You're looking good here. Okay, we're going to be busy for a minute. After arm on, take care of the descent. I'll get the stuff prepared. Very smooth touchdown. That's good. It looks like we're bending the oxidizer now. Roger, Eagle, and you are stay for T1. Over. Eagle, you are stay for T1. Roger. And we see him stay for T1. Roger, and we see you venting the ox. Roger. Radar circuit breaker. Copy, now 60, now 43, over. Roger, we have it.
Yes, sir, I read Columbia on the high gain.
Roger, we read you 5 by Columbia. He has landed Tranquility Base. Eagle is at Tranquility, over.
Yeah, I heard the whole thing.
Well, good show.
Fantastic.
Top reset.
The next major stay, no stay, will be for the T2 event. That is at 21 minutes 26 seconds after initiation of powered descent.
Columbia went up telemetry command reset to reacquire on the high gain.
Copy out.
We have an unofficial time for that touchdown of 102 hours, 45 minutes, 42 seconds, and we will update that.
Eagle Houston, you loaded R2 wrong. We want 10254. Roger.
Magnificent job. But we see why now it took a little longer than planned.
Now we'll get to the details of what's around here, but it looks like a collection of just about every variety of shape, angularity, granularity, but every variety of rock you could find. The color is well, it varies pretty much depending on how you're looking relative to the zero phase point. There doesn't appear to be too much of a general color at all. However, it looks as though some of the rocks and boulders, of which there are quite a few in the near area, looks as though they're going to have some interesting colors to them. Over. Roger, copy. Sounds good to us, Tranquility. We'll let you press on through the simulated countdown, and we'll talk to you later. Over. Roger. Okay, this 16G is just like the airplane. Right, Tranquility. Be advised, there are lots of smiling faces in this room and all over the world. Over. Well, there are two of them up here. Roger, it was a beautiful job, you guys.
And don't forget one in the command module.
Roger.
So that last remark from Mike Collins at an altitude of 60 miles. The comments on the landing, on the manual takeover, came from Neil Armstrong. Buzz Aldrin followed that with a description of the lunar surface and the rocks and boulders that they are able to see out the window of the LEM.
Tranquility, Houston, we have you pitched up about 4.5 degrees. Over. That's confirmed by our local observation. Roger.
Thanks for putting me on relay, Houston. I was missing all the action.
Roger, we'll enable Miss Finn relay.
I just got it, I think.
Roger, Columbia, this is Houston. Say something. They ought to be able to hear you. Over.
Roger, Tranquility Base. It sure sounded great from up here. You guys did a fantastic job.
Thank you. Just keep that orbiting base ready for us up there now.
They're talking.
Will do.
That request from Neil Armstrong. Here Mission Control, Flight Director Gene Kranz is going around the...
AOS 10327, AOS 10413, over.
Thank you.
Camera is focused automatically on the ladder, so that as Aldrin goes down, that is to say, as Armstrong goes down, the first man, it will be automatically focused on him. Then, by the way, this camera is turned on not automatically, but by a button inside the LEM cabin. Then one of the first things that happens is that Armstrong goes over and removes this camera, and part of the assembly is here. He puts this on, in this fashion, and then there's a tripod here. Remember, this all rides up in the bottom section of the lunar module. And if I can get it out without tearing this foil, here we are. This then is set out a distance away, perhaps 30 feet away from the bottom of the ladder, and the camera is turned on. This is the black and white camera, and it will be running all of the time they're on the lunar surface. And presumably, through that camera, we'll be watching all of the things that these two men do. Now, in addition, there are a number of tools which you may see here. First of all, I'll open this. This is called the Mesa table. It's not exactly a table, but it can be adjusted as to height, as you can see here. Of course, this will be in 1/6 gravity. And you can put the rock box on there, or you can do anything you want to. It gives you a kind of a working table, so you don't have to bend all the way down. Remember, it's not too easy for these men to do too much bending. Here you see the position that the two rock boxes are in. This is the way they ride to the moon. Now, riding back from the moon, of course, they wouldn't be in here because this is part of the LEM that stays on the moon. These two ride back inside the upper section of the LEM. We have here an interesting tool. Excuse me while I reach over here. A pair of tongs. This also saves the astronauts the trouble of leaning over. When they want to pick up a sample from the lunar surface, they take the tongs down in this fashion, pick it up like this, and put it in the sample bag. And this is going to be done many, many times. There is also, aboard the Mesa package, a scoop and a geologist's hammer, a core sampler, which will be driven down perhaps 8 or 10 inches into the lunar surface and then picked up, and there will be a core of lunar soil in that. That will be wrapped up and also brought back. And here is an extension handle which goes on top of the scoop, and also it could be used for the hammer. Now, in addition to this package and what all of the tools it brings, as you know, there are some mementos to be left on the moon. Included among them are the flag, about which we've heard so much. And the flag rides up on this side of the LEM ladder. And it opens in this fashion. We're not sure exactly at what point during the EVA that this will be taken out, but at any rate, it rides up in this part of the LEM, and astronaut Armstrong will then, excuse me, unfurl it. And as you've heard, since there's no air on the moon, no wind to blow it, there must be a piece on the back to keep it constantly as if it were blowing in the breeze, since it's going to stay up here presumably for a long time. He then puts it together in this fashion. I guess I have the wrong end here.
Peter?
Go. Yes, sir.
They had a device at the Democratic Convention with an electric fan in it to blow the flag. You remember that?
Yes, except they don't have too much power on the moon, David. I think that would be a great way to do. And we can't dig into our concrete floor, so somebody has provided a very nice little stand for us. I doubt that they'll find a stand like this on the moon. But this could be set up between a couple of boulders or perhaps dug into the surface. And presumably, Old Glory will wave forever on the moon unless a micrometeorite or something comes along to disturb it. There's one other thing that will be left. Requires no energy on the part of anyone except the opening of a little steel door, and that is the plaque about which we've heard. The plaque is affixed to this particular leg of the LEM. I don't know, there you can see it. It says, here men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind. And then there are the signatures of the 3 astronauts and President Nixon. So this, too, presumably, will be here for a long time. I might include one other thing. You notice a lot of foil, which wraps the legs and the bottom part of the lunar module. Now, this is not something that we've just put on here for show, or to give you an idea that it just came out of a box from Macy's. This is actually mylar coating, a very thin and very strong coating, and it protects the bottom part of the LEM from excess heat, either from the sun and in the landing phase, there's a great deal of heat generated by the descent engine. And as it gets closer to the moon's surface, that heat is reflected from the moon, and they wanted to be sure that it did not affect this bottom part of the LEM. And so that's why we have the foil. David?
Thank you, Peter. The 2 astronauts walking on the moon, as has been said, the real reason for all this elaborately engineered, meticulously designed pick and shovel equipment they're taking with them, is that when they get that spacesuit on, even though the gravity is only 1/6 of ours, they can barely move. They can't lift their arms any higher than this. They can barely bend their waists at all. And let's see, can they bend their knees, Frank? Only a little?
They can bend their knees a little and get into a kind of a squatting position to where their hands would reach something about 22 inches off the surface of the moon.
But if they dropped something, they couldn't pick it up, could they?
Unless they use their little tongs to pick it back up with.
Well, there's been a great deal of work, as you can see from that hardware Peter Hackes was describing. A great deal of work has gone into the design.
Both now and presumably in the future. You'll notice it's a rather cumbersome-looking affair, but rather necessary. Mr. Savage, why is it necessary, and what's he wearing?
Well, we're going to the moon where we don't have any atmosphere as we know it here on the Earth, Peter. It's necessary to provide 2 things. One, a pressurized garment to retain an atmosphere, and 2, a piece of equipment, mechanism for providing that atmosphere. Oxygen, water vapor, this sort of thing.
And what we have here is a cutaway version, presumably, of what he is wearing on his back.
Right. We're looking at 2 mock-ups here. The one on my near left is an exposed version of the pack without its thermal insulation that we see on this mock-up. This mock-up is the actual flight configuration covered with thermal insulation.
Let's go from top to bottom here and take a look at what we have.
We have 2 major sections to this equipment. The topmost section, this box at the very top, is an oxygen purge system, which is basically a backup system for the backpack itself, the PLIS or PLSS, which is the bottom section here.
This is what they call the OPS.
The OPS,
when we hear this
right.
on the intercom, or that is to say in the conversation, that's what they're referring to. This is the OPS, and this is what's called the PLIS, PLSS.
Right. These are 2 completely independent life support systems. This unit here being the primary system, this being the secondary or backup system.
And this in here, I presume, is the radio.
The radio, actually, Peter, is the small box on the very top that runs from here to here. That is the communication system. The box we're looking at right here, this flange, is the heat exchanger. You've probably heard it referred to as the sublimator, which is what actually rejects all of the heat of this system to the vacuum of space.
Now, what does this machine do for the man walking on the moon?
Well, in addition to providing the communications, the means for allowing him to talk to his fellow crewmen and talk to us back here, it provides a complete life support system which provides oxygen within the suit, provides heat removal from his metabolic expenditure, provides for the removal of water vapor, which he gives off as he breathes, provides removal of carbon dioxide, which he also gives off, and it supplies the water from a central tank here to the sublimator, which is then boiled to the vacuum of space for this heat removal that I've mentioned.
Now, suppose there were nothing to remove the heat of the man's body in his normal energy, whatever he's doing. What would it soon develop?
Well, in a very short period of time, his body would store heat, his body temperature would rise, and ultimately he would be subject to collapse from the overtemperature condition of his body.
In other words, then, Mr. Savage, what you're saying is that this portable system really duplicates what he's getting inside the spacecraft.
That is right. It does everything for him that the LEM, the command module, environmental control systems do, in effect on a miniature basis for a shorter period of time.
What temperatures does it keep him at?
It supplies oxygen to the suit at a maximum temperature of about 70 degrees. It provides chilled water through these two tubes that we see right here, which are circulated in a network of tubing on his body, provides that water at a temperature of between 45 and 60 degrees.
Can he regulate that to whatever temperature he desires?
He can regulate it. There are three different positions of a mixing valve right here, which is accessible to him, so that he can have that system in any one of three positions for minimum, intermediate, or maximum cooling.
Now, you say he's entirely on his own when he's wearing this. For how long can he go on his own?
Well, the system, the backpack, will provide for his needs for a period of up to 4 hours. The oxygen purge system, the unit on the top, can take care of him for up to 1/2 hour.
Well, briefly in conclusion, Mr. Savage, it looks good. How do you know it's going to work?
Well, I wish I could count the thousands of hours that we have put in our laboratories, in NASA laboratories, both at the Manned Spacecraft Center and at KSC, testing this equipment. We have thoroughly proven it. The astronauts have operated the actual equipment that's with them on this mission during simulated ground tests. All in all, we have a high degree of confidence that this equipment will function.
And it's also been used in space, has it not?
Yes, it has. It was used for approximately 1 hour on the Apollo 9 mission.
Thank you, sir.
Well, I believe him.
Yeah, hold it, going close, and I'll get the valve to, okay? And I better get up first.
Hatch reported coming open at 109 hours, 8 minutes, 5 seconds.
Okay, the valve's auto. Okay.
Correction, 109:07:35.
Load up to forward. Window cleared yet? The water window cleared yet? It was, yeah. Mine hasn't cleared yet.
Perhaps I should say again that we won't get pictures until after the hatch is open.
Over.
Armstrong has started down the ladder a couple of steps.
Columbia, go ahead.
Pulls a latch.
Columbia, this is Houston. We'd like you to cycle the fans in cryo-hydrogen tank number 1, and LOS time this orbit is 11119er31. Correction, make that for the next orbit. You already have the ALS LOS for this orbit. Have the ALS LOS for this. on my
wanted.
Roger out.
There's at least one thing that's not bothering anybody in this country anymore, and that was the fear that the Soviet lunar probe would land and scoop up some lunar soil and come back before the Apollo astronauts arrived there. At 3:15 this afternoon, Eastern Daylight Time, the Soviet control base in the Crimean went over the horizon and lost contact with the lunar probe, and it's unlikely that they would be able to do anything with it until tomorrow morning. It's still orbiting as far as we know, and at one point it went down as low as 10 miles above the lunar surface. It was in the same general area, apparently not at the same time as the Apollo landing. In Moscow, the Soviet news agency TASS said Luna 15 was within 10 miles of the moon at its lowest point. It added that the probe was functioning normally in its scientific exploration of lunar space. That's the last word we've had on it. They've apparently got the hatch open, and Commander Armstrong is more than likely either getting out or preparing to get out. He does it very slowly and carefully. He doesn't want to damage his suit. This model is in the NBC Space Center. We don't know whether that's what it looks like there with all those rocks or not. But he said he saw all sizes, and so we're probably as close as you can be without seeing it firsthand.
They've been on the PLSSs now for 16 and a half minutes.
Columbia, this is Houston. We show you nearing high gain antenna scan limits. When you lose lock on us, we request Omni Delta. Omni Delta when you lose lock, over. Delta. Delta when you lose.
Transmission.
Roger, Omni Delta.
Transmission up to Collins. And we've heard no more from the crew on the moon since they said they were opening
We're
the
8
hatch.
minutes away from loss of signal on Columbia.
To let the last pound plus of pressure outside the cabin.
Okay, my window's cleared. I'm going to go to... I might cooling up a little bit.
Okay, my window's clear.
They've got electric defoggers on their windows.
All
don't they?
RCU windows are clear. Family circuit is 4243. And I got FN pressure light, a 3 amp light, and an ECS light.
Downward separator light.
Houston, this Neil, radio check. Neil, this is Houston, loud and clear. Break, break, Buzz, this is Houston, radio check and verify TV circuit breaker in.
Roger, TV circuit breaker's in.
That's Aldrin turning on the camera.
5 clear.
Roger.
There's a
And we're
picture.
getting a picture on the TV.
Wheels upside down. Now it's right side up.
Now they've turned it right. Now we can see him moving down. Let's just enjoy this.
Okay, Neil, we can see you coming down the ladder now.
Neil, we can see you coming. Okay, I just checked getting back up to that first step. That isn't collapsed too far, but it's adequate to get back up.
Roger, we copy.
It's a pretty good little jump.
He's on the move.
Buzz, this is Houston. F2, 1/160th second for shadow photography on the sequence camera.
Okay. I'm at the foot of the ladder. The LEM footpads are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
I think he said one small step for man, but one giant leap for man. I'm not certain I got all that right.
The surface is fine and powdery. I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal, to the sole and sides of my boot. I only go in a small fraction of an inch, maybe an eighth of an inch, but I can see the footprints of my boots and the treads and the fine sandy particles.
Neil, this is Houston. We're copying.
There seems to be no difficulty in moving around as we suspected. It's even perhaps easier than the simulations of 16G that we performed in various simulations on the ground. Absolutely no trouble to walk around. The decent engine did not leave a crater of any size. It has about 1 foot clearance on the ground. We're essentially on a very level place here. I can see some evidence of rays emanating from the descent engine, but very insignificant amount. Okay, Buzz, we ready to bring down the camera?
I'm all ready. I think it's 2 miles squared away in good shape.
Okay.
Okay, you'll have to pay out all the LEC, Ned. Looks like it's coming out nice and evenly.
Okay, it's quite dark here in the shadow and a little hard for me to see that I have good footing. I'll work my way over into the sunlight here without looking directly into the sun.
Okay, it's taut now.
Unofficial time on the first step, 109.2420.
Okay, I think it's pulling the wrong one. Okay, I'm ready to pull it down now. There was still a little bit left in the... Okay, don't hold it quite so tight. Okay? Okay. Looking up at the LEM, I'm standing directly in the shadow now, looking up at Buzz in the windows. And I can see everything quite clearly. The light is sufficiently bright, backlighted into the front of the LEM, that everything is very clearly visible. Okay, I'm going to be changing it. Okay.
Surgeon says that
Camera installed on the RCU bracket.
Surgeon says the crew is doing well. Data is good, crew is doing well.
And I'm still in the LEC on the secondary struts. I'll step out and take some of my first pictures here.
Roger, Neil, we're reading you loud and clear. Let's see, getting some pictures and the contingency sample.
.35.5 minutes of PLSS time expended now.
We might orient you just a bit. The black upper portion of the picture is the blackness of space. The white lower portion, about the lower third, more or less, is the surface of the moon, illuminated by the sun. The black...
Neil, this is Houston. Did you copy about the contingency sample, over?
All right, you're going to get to that just as soon as I finish these picture series.
The shadow of the lunar module is the dark area to the lower left of your picture. And the leg of it, of course, you see going up through the middle, the white structure.
Might help out a little bit here too, David. According to the information we got on the way the spacecraft had landed, you're looking southwest on the moon. The ladder is pointing almost due west. It's 13 degrees to the south from due west on the moon, which would mean, if you're looking at it, the ladder is pointed to the left side of the moon, westward and slightly south.
Okay, gonna get the contingency sample there, Neil? Right. Okay, that's good.
Unless they're in some kind of depression, the horizon is usually about 2 miles away.
A little out of sequence on his chores there. He was supposed to get the contingency sample, the small first sample of the lunar surface as a first activity, and then go to the other. He reversed them a bit.
Okay, the contingency sample is down, and it's up sample.
He moved out of camera range to get that because they wanted to get a sample as far as they could.
It's very interesting. It's a very soft surface, but here and there where I plug with the contingency sample collector, I run into very hard surface, but it appears to be very cohesive material of the same sort. I'll try to get a rock in here. A couple.
Again, the reason he moved away was they wanted to get as far as they could away from where the descent engine put out its plume and disturbed the surface of the moon. And they want to get as pure a sample as they can.
It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here. Be advised that a lot of the rock samples out here, the hard rock samples, have what appear to be vesicles in the surface. Also, I'm looking at one now that appears to have some sort of phenocryst. Houston, roger out.
There's a precise...
Okay, the handle is off the... push it in about 6-8 inches into the surface. Like it's pretty easy to...
It is. It's, I'm sure I could push it in farther, but it's hard for me to bend down farther than that.
Didn't know you could throw so far.
You can really throw things a long way up here.
Precise quotation of the first words spoken by a man on the moon. One small step for man, one giant leap for mankind.
My pocket open, bud?
Yes, it is. It's not up against your suit, though. Hit it back once more. Or more toward the inside. Okay, that's good.
The TV camera
in the
is
pocket?
Yeah, push down.
fixed in this position for the time being.
Not all the way in. Push it.
In a few moments, he's going to take it off and mount it on a tripod away from the spacecraft, and so we should get a little
The
better look.
sample is in the pocket. My oxygen is 81%. I have no flags, and I'm in minimum flow. This is Houston, Roger Neil.
He's in good condition.
Okay, I got the camera going at 1 frame a second.
Okay.
And I've got 80%, no flags. Good.
Are you getting a TV picture now, Houston?
Neil, yes, we are getting a TV picture. Neil, this is Houston. We're getting a picture. You're not in at the present time. We can see the bag on the LEC being moved by Buzz, though. Here you come into our field of view.
Oh, let me move that over the edge for you.
Okay, ready for me to come out?
Yeah, just stand by a second. I'll move this over the handrail.
Well, he's moving with a great deal more confidence than he did initially. He's bouncing around now.
That's how you move when you lose 5/6 of your weight.
You're right. But not nearly as gingerly as at first.
Okay.
All right, that's got it. Are you ready?
All set.
And now Armstrong will make pictures of Aldrin as he comes down the ladder with the camera, and we'll see it from the other
difficulties
camera.
I was having. I'll try to watch your bliss from underneath here.
He really gets around with remarkable ease.
You know, they had prepared for all sorts of problems. Falling down, not being able to get up, not being able to get enough traction to move around, to start or stop.
All right, the backup camera is position.
Okay, your bliss looks like it's clear and okay. The toes are about to come over the sill. Okay, now drop your bliss down. There you go, you're clear. And laterally you're good. Got an inch clearance on stop your bliss.
Okay, you need a little bit of arching of the back to come down. How far are my feet from the
Okay, you're right at the edge of the porch.
Okay. Back in from... Small little foot movement. Porch. Arching of the back. Helmet comes up and clears the bulkhead without any trouble at all.
Looks good.
Armstrong returning the favor now and helping Aldrin position himself as he comes out the hatch.
45 minutes PLSS time expended.
I have to come down the ladder and
Neil, this is Houston.
join him
Based
on
on
the
your
moon.
camera transfer with the LEC, do you foresee any difficulties in SRC transfer over?
Negative.
He was in.
That's the sample return containers, the rock boxes that Capcom...
Now I want to back up and partially close the hatch.
He was asking Armstrong if the device they used to lower the camera worked well enough to suggest they would have little or no trouble getting the rocks back up, and the answer was no problem.
Particularly good thought.
That's our home for the next couple hours. We want to take good care of it. Okay, I'm on the top step, and I can look down over the RCU and landing gear pad. It's a very simple matter to hop down from one step to the next.
Yes, I found it to be very comfortable, and walking is also very comfortable. You've got 3 more steps and then a long one.
Okay, I'm going to leave that 1 foot up there and Both hands down about the fourth rung up. There you go.
And he jumped down.
Okay, now I think I'll do the same.
And the second man is on the moon.
A little more. About another inch. There, you got it?
That's a good step.
Yep. About a 3-footer.
Beautiful, beautiful.
Isn't that something? Magnificent sight out here.
Magnificent desolation.
Both PLSS is nominal on consumables.
Looks like the secondary strut have little thermal effects on it right here, Neil.
Yeah, I noticed that. Seems to be the worst, although similar effects are on all around.
It's very, very fine powder, isn't it?
Isn't it fine?
Right in this area, I don't think there's much of any but fine powder. Some clouds together, and it's hard to tell whether it's a clod or a rock.
Notice how you can pick it out?
Yeah, and it bounces and then
This television picture is going over most of the world. We've just got a report from Poland, Czechoslovakia, and Romania that the picture quality there is very good. And
reaching
Asia.
down fairly easy. Get my suit dirty at this stage. The mass of the backpack does have some effect in inertia. There's a slight tendency I can see now to backwards due to the soft, very soft texture.
Oh, you're standing on a rock, big rock there now.
Pad sure didn't.
No, it didn't.
That's no crater there at all from the engine.
No?
I wonder if that right under the engine is where probe might hit. I'd like that.
Yeah, I think that's a good representation of our sideward velocity at touchdown. That folded the probe.
I'll see that probe over on the minus Y strut. Broken off and bent back up.
That did, didn't it? The other two boats bent over.
Can't say too much for the visibility right here without the visor up. Pretty dark. It looks like there's a surface of a flat rounded rock. And incidentally, these rocks, very powdery surface.
Say again, please, Buzz. You're cutting out.
And here's some...
I say that the rocks are rather slippery.
Roger.
Very powdery surface. When it's on there, it's fill up all the very little fine porises. They'll tend to slide over it rather easily.
He's now doing a little work with the camera, taking the heat protection
Neil
device.
Armstrong getting ready to move the TV camera now out to its panorama position.
Traction seems quite good. Particular area. Start to lose my balance in one direction, and recovery is quite natural and very easy. And moving arms around, Jack doesn't go off the surface. Not quite that light-footed. And I have the insulation off the Mesa now. The Mesa seems to be in good shape. You have to be careful that you're leaning in the direction you want to go, otherwise you slightly inebriate the. In other words, you have to cross your foot over to stay underneath where your center of mass is.
Roger, you look okay as far as distance goes, Neil, and we'll line you up again when you finish the panorama. You're going too fast on the panorama sweep. You're going to have to stop for...
I haven't stopped. I haven't set it down yet. That's the first picture in the panorama. Right there.
Roger.
I see what he means about it having a stark beauty of its own. It is pretty.
Just about northeast. Tell me if you got a picture, Houston.
Well, we've got a beautiful picture, Neil.
Okay, I'm going to move it.
Okay, there's another good one.
Something on the horizon.
Okay, we got that one.
Okay, now this one's right down sun, straight west. And I want to know if you can see an angular rock in the foreground.
Roger, we have a large angular rock in the foreground, and looks like a much smaller rock a couple of inches to the left of it. Over.
Right, and then on beyond it about 10 feet is an even larger rock that's very rounded. That rock is about, the closest one to you is about sticking out of the sand about 1 foot. It's about 1.5 feet long, and it's about 6 inches thick, but it's standing on edge.
Roger.
But nothing to knock it over.
Okay, Neil, I've got the table out. Got a bag deployed.
We got this view, Neil.
I don't know what that is.
Straight south.
Roger, and we see.
All right, well, I think it's safe to say that my time and money were very much well spent. This is awesome. We have not only a clear picture and clear sound, but 1 hour of one of the most important events in U.S. and global history. July 20th, 1969, man lands on the moon for the first time. So, as for the other hours of this footage, I'm sure they're out there in the ether. But I was very fortunate to come across this eBay listing and bring this 1 hour of such a pivotal day in our history back to light. Now, of course, it is in black and white. There might have been a color component to this broadcast, but this machine was not recording in color back then, and Even if it was in color, I don't even have a color playback machine. So I hope you all enjoyed that, and if you have perhaps the other hours of this footage lying out there, or you have any half-inch reels, or let's just be real, any type of lost and dead media, you can send it out to Reis Restorations, REISS. Look us up on Facebook. Hope everyone enjoyed. Have a great day.